Okay, it's free body diagram time. So the first concept, we're calculating the torque in today's lab. And I hope you guys still remember how do we calculate the torque. To calculate the torque, you need a force and you need a moment arm. So in this case, you see the axis rotation is here. If you want to calculate the torque, the force would be F, which times the moment arm is R here. And a key concept, how do you find a moment arm? The moment arm should be perpendicular to the force, and it should cross the axis of rotation. So take a look at an alternative example here. You can see the force is here, but it's not that perfect, right? So how do we find a moment arm here? You need to find a moment arm which is perpendicular to the force and also cross the axis of rotation. So that will be the R will become here, which is part of this original stick. You need to times cosine theta to make the D become R. So R would equals to D times cosine theta. That will be part of the original moment arm. Okay, then we can jump into today's model. You can see here will be the upper arm. Here is a forearm. We hold a weight here, and the theta represents the degree, the angle between horizontal line and your forearm. L is the length of the forearm. To draw a free body diagram, we need to name the forces, right? So how many forces can you guys name? First, don't forget, always remember to name the weight. Okay, so you know the forearm has its own weight, right? Also, the other weight would be the F here, the weight of the object you're holding. All right, then if we want to calculate the torque, we need to find a moment arm, right? Remember the key concept, moment arm should be perpendicular to the force and cross the axis of rotation. So obviously, the moment arm for F, for the force here, will be this green line, right? It's perpendicular to the force and also cross the axis of rotation. How about the moment arm for the weight of the forearm? It's the same, right? It's shorter than the L cosine theta, but it's probably half of it, right? Also perpendicular and cross the axis of rotation. And this green line, use some trigonometry, we'll figure out it's L times cosine theta, right? So we can calculate it. The clockwise torque would be the torque generated by these two forces. The torque generated by the weight you're holding would be F times L cosine theta, force times moment arm. And also the clockwise torque generated by your forearm itself would be W times 1/2 L cosine theta, because its moment arm is half of the moment arm for the force. Okay, then what will happen if we change the angle? You can see if the angle is increasing, that means we're raising our forearm, right? And then how do you find the moment arm in this case? That will be here, right? It's shorter. So we can conclude that when the theta is increasing, then the moment arm will decrease. That means the force will generate less torque. Okay, and that's all about the clockwise torque. But how about counterclockwise torque? We all know that it's generated by your bicep muscle, by your elbow flexor muscle, right? Okay, so how do we find a force? Easy. But how do we find a moment arm? In this case, it's a bit harder. It should be crossing the axis of rotation and also perpendicular to your force, right? So you can imagine that'll become this one. We call it C. You can see it's perpendicular to the force and also cross the axis of rotation. So you can calculate the counterclockwise torque, or equals to F muscle times C, right? Force times moment arm. All right. And if it's in a static situation, that means you're holding the weight still, then the clockwise torque should be the same as counterclockwise torque. So these two equations should be the same to each other. All right. We got 3 classes of your lever system. The first class lever will be the axis of rotation will be in the middle between the effort and the load. The effort is usually your muscle force. And second class lever will be load is near the axis of rotation, and your muscle force is further. Your muscle force got a larger moment arm, which will give you mechanical advantage. And the third class lever, which is in our arm model, you can see your muscle force has a less moment arm, and your load has a longer moment arm, which will give you mechanical disadvantage. You need to generate more force to counter for the torque, right? But what's the pros for third class lever? You see, if your muscle shorten a little bit, your hand will move a lot, so it'll be more efficient. It's easier to generate a higher velocity or larger displacement with really little muscle length change. So in our arm model, it's a third class lever. All right. So what are the change of the angle contribute to the moment arm of the muscle force? You can see if we move our arm up a little bit, the moment arm is here, which is closer to the distance between the attachment side to the axis of rotation. We know this red line is not changing, right? Because the attachment side is not changing. So if the moment arm is closer to the red stick, to the red length, that'll be the maximum you can get of your moment arm. But if we move our arm upper more, it'll become like this. So the C is not the same as the red stick. It's smaller than it, right? So from here, C is less than the distance between attachment side to axis of rotation. And there's certain angle that the moment arm will be the same as the length from the attachment side to the axis of rotation. Then that's the maximum of moment arm you can get in this situation. And then if you move your arm upper more, then your moment arm will decrease then. So your moment arm will increase to here to reach its maximum and then decrease after you keep moving your hand up. Okay, so that's a change of angle contribute to the moment arm of your muscle force. But remember, when theta increase, the moment arm for this blue object will always decrease. Okay, so that's all the concept and the free body diagram we need to calculate for today's lab. Hope that gave you more sense of when you want to answer the question in the assignment. So in next video clip, I'm going to demonstrate the data collection. So make sure you have your lab manual that you can put the numbers into. All right, I'll see you guys later.